Hello, this is question 16 on your June 2019 paper 2 from AQA, and you have an elite athlete runs in a straight line to complete a 100 meters race. During the race, the athlete's velocity v is modeled by this expression. We have an exponential where t is the time in seconds after the starting pistol is fired. Find the maximum value of v, giving your answer to one decimal place. So if we want to find the maximum of an expression of this function, we are going just to derivate and make it equal to 0. So we are going to do dv by dt equal to 0. Dv by dt is derivative of this one is 0. Derivative of this one, I multiply minus 11.68 by minus 0.9. So it becomes positive and is 10.512, and then e to the same power, and the next one is minus 0.03 times 0.3 becomes stays negative, sorry, and is minus 0.009 e to the same exponent. That's the derivative, and that's what must be equal to 0. We are going to reorganize the equation in a way that is easier to solve. So we are going to write this in the denominator. So we have 10.512 divided by e to the power of 0.9t is going to be equal to 0.009 e to the power of 0.3t, which means multiplying by e to the power of 0.9t, I have 10.512 is 0.009 e to the power. When I multiply powers, I add the exponents, so e to the power of 1.21t, which means that e to the power of 1.t is 10.512 divided by 0.009, which is 1168. And then taking logs, or taking ln, I have the 1.2t is ln 1168, which means that t is giving your answer to one decimal place. I was checking if we have to give the answer. So it's ln 1168 divided by 1.2. This is 5.8858 seconds. This is the time when the velocity is maximum, but they are asking us to find the velocity, find the maximum value of v. So this is like having y in terms of x, finding when what x is for the maximum value, and then substituting to find the y, which is the maximum value. So we need to find v, substituting the x, the t, by this value here. So maximum velocity is going to be when t is 5.88. So you put this value in the memory of the calculator, or just substitute this by ounce to get the most accurate value, and then you run at the end. So you will have 11.71 minus 11.68 e to the power of minus 0.9 times that value that I have there. I'm going to copy just a bit, but you should use the whole number. 0.3 e to the power of 0.3 times 5.89. You get 11.467. Round to one decimal place is 11.5 meters per second, one decimal place. And it's a lot of marks, so it's 8 marks, and it says fully justify the answer. So we have found the maximum velocity, but we should really show that it's a maximum and not a minimum, because we know derivative is 0, but we should check that it's a maximum. We obtain only one value of t, which means it should be the maximum that they are asking us. But I would just check with the second derivative. I think it's the best way, just to be sure, and that works in every question. So we derivate again. We have this one, dv by dt, so we differentiate this expression. So we have 10.512 multiplied by minus 0.9 is going to be minus 9.4608 e to the same exponent. And when we differentiate this one, we have minus 0.009 times 0.3, which is minus 0.0027 e to the same exponent. And this is going to be negative for any value of t, yeah? So for any t. You can substitute if you want, so you can substitute this value of t here, and it's going to be negative, yeah? So if it's negative, that means it's a maximum. Yeah, so I couldn't miss this part here. Yeah, you have to justify it's a maximum. When they say fully justify, you should do that. Unless in part B, for example, they say something like using the second derivative show that this is a maximum. That sometimes they do, yeah, but it's not the case. Then find an expression for the distance run in terms of t. So what we are going to do to find the distance is to integrate the velocity. Yeah, we are going to integrate this expression. So the distance is going to be integral of v dt. So the 11.71 minus 11.68 e to the power minus 0.3 t. No, 0.9. Minus 0.09 t and minus 0.03 e to the power of 0.3 t dt. This is going to be 11.71 t minus 11.68 e to the power of the same, but divided by minus 0.9. And minus 0.03 e to the power of 0.3 t divided by 0.3 plus the constant of integration. We can work the coefficients. So 11.71 t plus, so it becomes a plus. I'm going to leave the fraction because the decimal is not very nice. E to the power of minus 0.9t, and this one is 0.1, so this one is fine. 0.1 e to the power of 0.3t plus c. So the only thing I've done is dividing the coefficients to have something nicer, yeah? Expression for the distance. So this is the expression, but I am able to find this constant because I know that the beginning of the race, so when t is 0, the athlete is not running, so the velocity is 0, so I can find the constant of integration using that. So this velocity is 0 when t is 0, so this is 0, so I have 0 is going to be 584 divided by 45, e to the power of 0 is 1, and this one again is 1, so minus 0.1 plus c, and from here I get c. So c is going to be minus 1159 divided by 90. So my expression for the velocity in terms of time is going to be just this one, but I'm going to add the c that I just found. So 11.71 t plus 584 divided by 45 e. And you can divide these coefficients and round them. I'm just leaving them as a fraction because they are not nice decimals, yeah? You will have to round them, so I think it's better to just leave as a fraction. So this is your expression for the distance. Sorry, I don't know why I wrote velocity. So distance is that expression, yeah? We have integrated velocity. And the next part, it says the athlete's actual time for the race is 9.8 seconds, comment on the accuracy of the model. So we have an expression that gives us the distance in terms of the time. We know the distance is 100 meters. So what we can do is to check or substituting the distance by 100 and find the time and check if that's similar or close to 9.8, or the other way around, which I think is easier. Substitute the time. So we substitute the 9.8 and find the distance and compare with the 100 meters. Yeah. So that's what I'm going to do. I'm going to make t equal 9.8 in that equation. So the distance is going to be 11.71 times 9.8. 5 times 4 plus 45. And the last one, I'm just substituting in the expression, yeah? Minus 0.1. And when we do this, we get 99.99 meters to 2 decimal places. So I have rounded to 2 decimal places, which is very, very close. Very close to the 100 meters. Therefore, it's a very accurate model. Yeah, so write a conclusion, something like this, because one line is going to be for you working out and the other to decide if it's accurate or not. Yeah, and that's all with this question.